Okay, so here we're going to take a look at the factor theorem, right? So according to the factor theorem, k is a zero of f of x if and only if x minus k is a factor of f of x. All right, so what this theorem is telling you is that now remember factor, we have a remainder of zero. So it's allowing me to use synthetic division to determine if something is a factor or zero of f of x. All right, so the way we're going to do that is let's kind of use this to do an example here. All right, so for this example, I would like to use the factor theorem to find the zeros of f of x equals to x cubed plus 4x squared minus 4x minus 16, given that x minus 2 is a factor of the polynomial. All right. Okay. So we want to find the zeros to this cubic. Right now, one thing to notice or to kind of understand here is that if I have a quadratic function, I know how to find the zeros to that, right? I can either factor that trinomial, right, using methods that I've learned in previous courses, right? Or I can use the quadratic formula, right? If there are no, if it is an unfactored one, or simply I just don't know how to factor it, the quadratic formula will always work, right? So I'm going to use the factor theorem here once, and then the resulting polynomial, when I use synthetic division here, is going to be a quadratic, and from there I'll just use previous tools that I know to find the other zeros. All right, so x minus 2, that means x equals 2 is a 0 here. So let me set up my synthetic division. 3, 2, 1. All right. Setting up my synthetic division, bring the 1 down. 2 times 1 is 2. That's 6. 12. What is that? 8. 8 times 2 is 16. And 0. Right? So we verify that it is a factor. But more importantly here, since we want to find the zeros, I've now found that I can factor it in this form, right? X minus 2, and the polynomial that's left is x squared plus 6x plus 8 equals to 0, right? Since it is finding the zeros, right? So we just set that f of x equal to 0. Okay, so from here, just looking at this, I said, all right, here I have a trinomial here, quadratic, and I know I can factor it, right? 4 and 2 multiplied to 8 and that up to 6 is equal to 0. All right, so x squared, 2x, 4x, 6x, 4 times 2 is 8. And now I found essentially all my zeros, right? So the zeros, x equals 2, x equals to negative 4, x equals to negative 2. All right, now the thing that made this possible here was that I was given that x minus 2 is a factor, right? So, all right, so it's a factor, so I know it's going to be a 0. Now the question becomes here, well, what if I wasn't given that, right? Again, I can use the graph as well, right? This is a non-graphical way to do this, right? It's just another tool, right? If I didn't have a graphing utility at my disposal, but I did need an initial value here that I needed to be able to plug in. So now the next question becomes, well, how can I get started if all I have is the polynomial function, right? What if I just had this, right? And then where do I go from there, right? If I didn't have a graph, all I had was this equation. Should I just be trying any numbers? Like, 1, 2, 3, etc. Okay, so that's where our next theorem, in the next kind of a video that we're gonna do, we're gonna go into, well, what if I wasn't given this, right? How can I get started on this problem, right? Now we are gonna guess at these values, but they're gonna be more educated guesses with some theorems behind it that'll narrow down our choices, right? It won't just be any integer; it'll be integers or rational numbers, I should say, that satisfy a particular property.